Okay, thank you. Welcome to the Ethereum 2.0 Serenity call number 10. People in the YouTube chat box, please let me know if and when you can hear us. And if any of y'all are monitoring YouTube, let me know if it transferred over correctly. Cool. Let me pull up the agenda. Here are YouTube folks. Here's the agenda, and also I have too many windows open. Sorry guys, 1 second. And Zoom, here's the agenda. Cool. So let's go ahead and get started. We'll start with client updates. I know there's some people on this call that haven't been here before. Let's do client updates, and if you haven't been on the call and your client comes up and you want to introduce yourself, please do that. And then afterward, if you're not involved with the client and you want to introduce yourself, do that. I'm hearing a lot of typing from somebody. Maybe Raul, can you mute, please? Cool. Great. So let's get started. Who wants to go first? Clients. Raul, can you hear me? How about Prismatic goes first and Raul mutes his mic? Am I not? I don't think I can hear anyone. 1 second. Test. Can somebody unmute and talk to me? I can't hear anything.
Yep, hearing you loud and clear.
Oh,
Can you hear me?
Yeah.
Same here.
Did someone from Prismatic begin?
Did you ask, did they?
Yeah. Did anyone start the client things? Sorry, I think my audio was out of whack.
No, no one has started.
Okay, great. Paul, I can hear you. Let's have you start us off.
Okay, sure. So we are ready. So we've been implementing gRPC APIs and spec, of course. We've started our validator service, which is pretty cool. So that's starting to come along pretty well. Focusing on the runtime and RPC at the moment, and then doing safety a bit later. One of our security guys, Mehdi, has started looking at adapting the Eth1.0 C++ fuzzer to try and point it at Eth2.0. So that can hopefully benefit everyone. We're kind of looking into as well a research thing as to how we can do hashing to G2 in Milagro. It's not as easy as we thought it would be. But yeah, that's about us.
Great, thank you. How about parody? And we have Wei here, maybe for the first time on the call, if you want to do a quick intro.
Hi. Around beginning of the month, we finished the version of the LMD Ghost first twice.
Can you get closer to your mic? I'm sorry, we're having trouble hearing you.
Sorry. Is it better now?
Yes, thank you.
Okay, around beginning of this month, we finished the version of the LMD Ghost first twice implementation in Substrate, and it's rather not really optimized, and we always recalculate the score on the fly, and there are a lot of other optimizations we can do. And right now we are working on the refactoring in Substrate so that we can support the the invoke fork twice per slot rule in the Infinity Trinity and yeah, because we also need this for the Polkadot Taro chance, so we need to do that either way. And yeah, that's the part.
Great, thank you. If you could point us to where LMD fork choice is implemented, we'd love to take a look. And if you have any metrics on kind of efficiency in processing, we're curious too.
Okay, yeah.
Thank you. How about Nimbus?
Hi. As usual, we are keeping in sync with the latest spec changes. In the past 2 weeks, we also focused on documentation, continuous integration, and reproducible builds. Regarding BLS, we implemented our scheme 4, and this time we copied the Harmony approach, but we still need to ensure that we are compatible with the spec. And so we'll be providing Python test vectors this week so that everyone can test their BLS implementation with the test vectors, and those will be built using PyVM Trinity, as a backend. We also have a basic fork choice rule implemented with LMD Ghost, but without justified or finalized slots. And the libp2p daemon wrapper is done for NIM. It works for Unix, but we are waiting for the libp2p team to improve Windows support. And for next steps, we want to implement block storage because currently we only are using in-memory tables for the different blocks, and we want to focus on the sync.
Awesome, thank you. How about Harmony?
We've been starting to work on the implementation from scratch about a month ago. This is because previously we work inside of Ethereum J code base, which is licensed under LGPL, and we don't want a new client and new library license under this license, and there is no feasible way of extracting the code from Ethereum J code base and just moving it to some to a separate repository and setting up a different license. So we started from scratch, and we're doing a pretty good progress so far. And we're aiming to release a standalone Beacon Chain client like in the first week of February. So far, we have implemented BLS, simple serialized database infrastructure, all core Beacon Chain structures, and the consensus is almost done. We yet not the things that are left is our fork choice rule, a validator service, and proof of work chain integration. And I think that we will manage to get this implemented by the end of January. I'll post a link to this new repository right now. It's not there is no license set up for this repository yet. I need to be careful here, but we are choosing between Apache 2.0 and MIT, or the third option is to license it under both licenses on the client's choice. So
cool.
here it is. Yeah.
Thank you. Sorry that you got tied up with licensing and had to redo a bunch of work, but I'm glad to hear you all are making progress.
Yeah. Thank you.
Maybe you could ask the people writing Ethereum G if they are willing to allow you to relicense part of their code to MIT or something.
We were thinking about it, but it's about 70 contributors in Ethereum J, and I don't think it's feasible to contact them all and to. I mean, yeah, it might be feasible, but it will require a lot of work on this point. So I don't even know if all of them are available at this time. So that could be a big issue.
Okay.
And we decided to start from scratch a month ago because that was the best time to start from scratch. I mean, that time the spec is still being in flux, and it's still in flux, but yeah, that probably was the best point to start the new repository.
Great, thank you. How about Pegasus?
Hi. Over the past 2 weeks, we added 2 more collaborators onto the project. We defined the primitives from the spec. We implemented the slot processing logic that's detailed in the state of the spec, and then the other stuff's in this spec. And then we started epoch processing. We laid out scaffolding for our libp2p interface. And we shifted to a microservices architecture. We think like long-term that'll be beneficial for projects like Infura, who kind of want to host like super nodes. And we're kind of continuing our talks with Harmony about kind of combining our efforts in Java client.
Cool. Thank you. How about ChainSafe, Lodestar?
Hey, yeah. So we sort of been getting a little bogged down with like these spec changes. So we've been spending a lot of time kind of architecting and doing the supplementary, working on our supplementary repos like Simple Serialize and BLS, and they're coming along. They should be done pretty soon, and we can integrate them, actually like start using them in the Beacon Chain client. And due to kind of spec change, we decided internally to kind of every 2 weeks we'll do an update unless something drastic happened in the spec. That way we can actually like get some progress going consistently for like 2 weeks straight, do a update and continue on that way. Outside of that, we started looking into JSLib P2P to kind of see if there's any holes that we can plug, because there is a bit of a discrepancy between some feature sets between that one and like the Go client, for instance, or the Go version, for instance. So we're looking to try to help them out and fix some of their stuff up. And that's about it for us.
Great, thank you. How about Xiaowei with IBM?
Hi. So we moved our Ethereum 2.0 state transition code base to the Trinity repository. And here's an overview document that I'm posting to the room chat. And most of modification from our side are on the client infrastructures and the Beacon Chain block syncing. And also the Pi SSE refactoring and finished the tree hashing functions. And Yannick proposed the test format, and we can discuss that later after the regular updates. That's the updates from our side. Thank you.
Thank you. How about Prismatic?
Hey guys, Raul from Prismatic here. Since the last update, we've had a lot of productivity. So we finished up the state transition function with block processing, epoch processing, up to the past few days in the spec. There have been a few more changes in there that we're still working on. We did a chain start listener that monitors the proof of work chain and kicks off the beacon chain after listening to a certain amount of deposits. We have a simple deposits try also implemented in Go that tracks the stuff and is listening to the latest contract. We're going to be using the Viper contract just to make sure that we're not doing anything with Solidity, and we want to make sure that we're using what the spec is using. We're implementing health checks for all of our services in our node just to make sure that when everyone's running it in production, things are smooth. We started on LMD Ghost fork choice rule with the most naive implementation. It's currently pretty slow, around like 800 milliseconds to select a new head. And I think Vitalik mentioned that things should be around 50 milliseconds with 100,000 validators. So we're aiming to optimize that over the next update. And thanks to Terrence from our team, we removed shard committees from the beacon state, which took a while because that was basically everywhere in our code base. Another cool thing I want to share with you guys is we have a YAML test for full state transition without epoch processing. So everything related to slot processing and also block processing is done. So I'll link you guys here in the chat, kind of where that is. Oh, Terrence already sent it. Thank you, Terrence. Yeah, so you guys can check that out, play around. We can basically simulate like, hey, we want 64 state transitions. I want you to skip these blocks at these slots, simulate like a proposer slashing, simulate like an exit. So you can do a bunch of different simulations and see what happens in the end. We want to use this for like our end-to-end suite. So yeah, YAML has been really useful, and building out the simulated backend has been really good for us so far. Yeah, aside from that, we're just, we really want to wrap up fork choice rule and make it optimal. So that's it.
Cool, great. Sounds like good progress. And then we have Dean has joined us today. Dean's been hacking for the past few days and wants to share some updates on his end.
Hey, so I started implementing the spec in Swift. I'm currently done with most of the helper functions. The next step for me is to implement simple serialize and the BLS stuff, and then probably start working on the fork choice rule.
Cool. Is that all of the clients? I think I got everyone. Speak now if I didn't. Cool. And I said if you wanted an intro, now's a good time. Maybe Stan. I don't think we've seen you on one of our calls, but I've seen you in the getters a lot.
Hey, so I'm Stan. I'm between jobs. I work on random projects, and one of those random projects happened to be Lighthouse. I've been contributing for about 2 weeks, and well, I've been trying to get up to date with the spec by attending the calls and reading it, obviously. I've been looking at some issues. I've pushed some 2 tiny PRs into the spec, and well, I intend to work more with you guys on landing this thing. Thank you.
Cool. Glad to have you. Anyone else want to get a couple words in, intro?
I do a quick one because I also just recently joined. I'm Christoph. I work on the Trinity team, and as you may know, Trinity is an Ethereum 1 client as well. So my main work is not so much ETH2 spec related, but more making sure that we integrate the ETH2 smoothly to work alongside the ETH1. So Trinity will continue to serve both chains.
Great, thank you. Anyone else? Cool. Next up is research updates. Who wants to get us started?
I'll start on my side. So I spent some time working on improvements to, or coming up with ways to optimize the LMD Ghost implementation, which some of which I put into that file in the Ethereum research repo. It's in the Ghost folder, and I think Prismatic has already been doing some updates based on those ideas. So I'm really looking forward to seeing more client teams actually implement Ghost and actually try running a chain with a fairly large number of validators, and just seeing how long all the state transitions take, because I think it would really help us in identifying whether everything is fine or whether we need to kind of try to work harder on Fortune's rule algorithms to come up with some mechanism that's more efficient. Also, I've been thinking about light client stuff, and that one GitHub issue that I just published a couple hours ago today, and where basically what I suggest is that we commit the list of active validator indices into the beacon chain state, and we keep a recent history of those around the same way we keep a recent history of random mixes around, and that would then make. And then when we do the get shuffling for crosslink committees and persistent committees around that, and that then calculate committees even for light clients that only have the block headers, and they would be able to do everything else with just Merkle branches. So that's out there. I think it's still the most recent GitHub issue, and it would be really nice to get more thought and review on that. Otherwise, there's some small things I made at PRs to make it so that the proof of work chain voting isn't just on the deposit vote routes. It's one block hashes, but I think that already got merged.
Great, thank you. Does anyone else have research updates?
On my end, one of the main things has been light clients. I've started thinking about those. I guess historically I've kind of ignored them somewhat, and they're harder and more subtle than I thought, and the design space is quite large to an extent. So I'll be reviewing the various proposals by Vitalik and trying to improve them where I can. In terms of kind of logistics around the GitHub the GitHub repo, I'm going to try and move things a little bit faster, so try and close down old issues that have been addressed or that are stale, try and move faster on the PRs. And I think one thing which might be a good idea is to avoid working directly on master. So we have, for example, like proof of concept releases that are spaced out by, let's say, 6 weeks. And then we work on some sort of scratch pad that is outside of master.
I generally agree. I think we can probably cut a version maybe at the end of this week or the beginning of next week, and then begin to work on a dev branch. I think that's definitely appropriate at this point, and that'll help. Like ChainSafe was discussing how they're going to just be targeting like snapshots, so we can begin to give those snapshots to people.
Yeah, and that will allow us to make change logs as well, so that you can wrap your head around the various different snapshots faster. Another thing is the VDF. So a lot of progress has happened. We're moving forward with Filecoin on some of the studies, involving various studies around VDF. So a lot has happened, and we will have a VDF day on February 3rd, and various other VDF activities on February 4th and 5th. So quite a bit is happening behind the scenes, and there will be even more stuff that will happen around these days. And so I'm hoping to write an update communicating all the progress that have been made sometime in February.
Great, thank you. I'll join you on that quest to move quickly and try to get all this stuff closed out. Still targeting something pretty clean and stable January 31st. Great. How about anyone from the Pegasus research team?
Yeah, not much on our side. We're still working on the signature aggregation, and we took us some time to get the Amazon nodes. We've got them just today, so we're starting to test, and hopefully we'll have results in the next 2 weeks, as we're presenting in 2 weeks actually.
And can you give us a quick reminder of what you are testing?
Yes, so we've written a protocol to aggregate signatures, BLS signatures, thousands of BLS signatures in basically 1 or 2 seconds. So on the simulation, it works. And we've done an implementation in Go that we're going to test on 3,000 nodes. And we expect to have something in 2 seconds and something like this.
Great, very exciting. How about Leo? Do you have any updates for us?
Yes. Let me see if I can share my screen. Can you see it?
Yes.
Yeah, okay. So I have been working on a way to visualize the results of the simulations. Sorry if my voice is a bit broken. I'm a little bit cold. I got a cold. So yeah, the idea is to visualize, because the simulations produce an awful amount of data. It has 5 levels of verbosity. So I have been working on a way to visualize the data. And so here is what I came up with. This is the result of a small run that I did today, 1 hour ago, more or less. And so it runs on 4 MPI ranks, and so it simulates 64 nodes. So it's a small network. And here you can see the network that is produced. You can see the light nodes here are nodes that have many peers, and the dark blue nodes are nodes that have less peers. So in the configuration file, one can decide the minimum number of peers that each node will have. And then here you can see a figure that shows the number of peers for all the nodes that are being simulated. I don't know if this is representative of a real client at this point, but I think for this run I set, because it's a small network, I set the minimum number of peers to 4 nodes. And then here you see the list of nodes. So when you click on one of those, you can see basically the main chain. At this point, none of this visualization part is showing anything of the beacon chain or anything of the charts, because I just started working on this. But basically, you can see all the blocks, the number, the hash, the parent, and the miner, and the time it has been mined, and you can see the entire chain. You can also see the anchor blocks. In this case, we have 3 for this simulation, which is about 55 blocks long. And then here on the bottom, you can see the peers of these nodes. So when you click on any of the peers, you can see, again, the chain, which should be the same chain. And you can also see the anchor blocks for this chain, if we see exactly the same, and so on for all the nodes. Yeah, so this is more or less what I have been working on the last 2 weeks. If you click on the bottom of the page, it guides you to the repository. So it's available online. Here you can see all the code and how to run it. I just added the instructions on Ubuntu because this is what I have been working on. But I would probably add instructions for other distributions. I mean, it doesn't change much actually. And so this is again for a blockchain that is not sharded at this point. I have other versions that include the beacon chain and the shards. Those are private. I haven't added those into this repository yet. My plan is to slowly start adding those features inside this repository and also adding nice ways to visualize the results of the simulation. Yeah, so I think that's pretty much it. I will share in the chat the link if you want to see the visualization of the simulation yourself, and I can also add the link to the repository if you want. Yep, and that would be pretty much all on my side.
Cool, great, exciting to see some progress on that front. Thank you.
Can I ask a quick question about this? Says Alexei.
Yes.
Yes,
so,
sure.
Leo, so what is the what are sort of hypotheses you want to test with the simulations?
Yeah, so there are several things that we have discussed in the previous calls. One was about what happens when the number of validators is not as high as one we would desire, and how fast the crosslinks will happen in that case. Another question is basically, I think, what it was posted on one of the simulation emails about simulating anchor rate versus number of transactions per block. So that could be another interesting thing to simulate. And well, I think there are several other things that we could do with this simulator.
Uncle rate of probably the beacon chain given network latency might be interesting.
Yeah, that as well, indeed. Yeah.
Cool. Thank you. Can you unshare your screen? I don't know how to get it back in the right setting.
Let me check on it. Yeah.
Cool. I just disabled sharing. Great. Thank you. Any other research updates before we move on?
I have a question regarding research. Is this a good time to ask?
Yes, absolutely.
I've seen a few posts on specification, the current beacon chain, and those are very insightful. Thank you for that. As a client implementer, what should we be aware of? And do you think any of these structure changes will go into phase 0?
I think definitely not phase 0 at this point, given that we're trying to wind down and any further changes to the spec that aren't critical to phase 0 at this point. At some time later, I think it's still there's still some details that are in research mode, particularly around finding ways to increase efficiency. So I think it would be nice if we could maybe after another month or so of working on and continuing to improve the spec, for there to be at least one team that would try to actually take it and make an implementation of it, just so we can see how difficult it is and what the efficiency issues and what some of the other results are. But it's still it's still definitely further away than stage 0 at this point.
Great, thanks.
Cool. Any other research, anything before we move on?
Another thing that we'll probably do is a Reddit AMA for Ethereum 2.0 research. So if you have questions, that will be a great opportunity to ask them.
Yep. Okay, research. Going once, going twice. Moving on.
Danny, sorry,
yeah.
Sorry, didn't unmute on time. Just wanted to ask Vitalik if you could clarify a little bit more about fork choice optimization for people that might not be as familiar here with LMD Ghost. Like you meant, I think the big culprit for like the inefficiency is counting the votes and figuring out the block ancestors. But just wondering, what you had in mind with your Python code.
Yeah, so one of the largest optimizations that I had in is basically that instead of treating every single validator as a separate unit, you would store a list of the most recent block hash that every validator voted for, but when you calculate the fork choice rule, you would treat everyone who voted for a particular block hash as a kind of single block, and that reduces the number of kind of units you have to worry about and calculate over, potentially from like many thousands to a few hundred, which makes things a lot easier. Also, there's some small tweaks in terms of how you actually calculate the ghost fork choice rule. So there's this binary search mechanism for finding the largest hash that's still, or the most recent block that still has over 50% support, and that's something that I've managed to speed up. Well, first from O of n if you do it really naively, then to O of log n if you do or O of log cubed n if you do a binary search based thing, and now it's down to O of log squared n. And then there's a bunch of various small scale tweaks to make it even more efficient.
Regarding optimizations that I wanted to try on the fortress rule, one thing is a data structure called a Fenwick tree, or also binary indexed tree, and it's used to keep track of prefix sums. So on how do you say that? Like that keeps being updated, and everything is log n. And another thing is that since we have everything coming in committees, instead of tracking every single validators, just track at the committee level. But I didn't implement yet in NIM. I just use a very naive one, and but I hope to speed up a lot the fork choice.
Cool. Curious to hear how that goes. Okay, moving on from research. Anything else before we move on? Great. The next thing is a post in the agenda from Alexi primarily about how to deposit an alternative mechanism on depositing for validators from proof of work to proof of stake beacon chain. Alexi, do you want to give us a quick briefing on your thoughts there?
So yeah, thank you very much. So I've listed the four in the post. My post, I listed 4 different points that I don't want them to be addressed now, but I want people to start thinking and perhaps point me to the part of the specification which already answers those questions. But I also present my initial thoughts about how to kind of improve the state of things on them. So number 1, some people already talked about it, a finality gadget on the proof of work chain, which is it going to be possible? How soon is it going to be possible after the introduction of the beacon chain? So I've seen some posts on the research, ETH research, but I didn't get into much of the detail. What are the details? So second is the tapering off the proof of work rewards. So essentially, I don't think it has been figured out yet. So how are we going to stop the proof of work rewards inflating the supply in Ethereum 2.0, because then it will be sort of competition between the miners in proof of work and then validators in proof of stake in terms of the supply of ether. And here my suggestion is kind of not very thought through, is that if we implement the finality gadget as described in the first point, then it's possible to tie the mining reward with the remaining ether supply on the proof of work chain. And since the clients, proof of work clients, will have to start watching the beacon chain to implement the gadget, they could also consult the beacon chain about what is the remaining ether on the proof of work chain. And so the smaller remaining ether, the smaller is the reward or something like that. I haven't thought it through, but it's one of the ideas. So number 3 is another thing that I started to think about, is that the risk of the beacon chain validators essentially coming in, getting their deposits in, launching the beacon chain, and then not letting anybody else come in. So essentially becoming the kings of the and queens of the Ethereum 2.0. And at the moment, I think in the current spec, it's designed so that they have to vote on let's say the proof of work block. But what if they don't vote? Is there any penalty for them to basically just sealing the door once they come in? And here, one of the ideas I had is to basically tie the validator reward in the proof of stake with the fact that they actually letting other people in. So it means that if they stop letting anybody in, then they don't receive rewards. Of course, it has a problem that if the proof of work chain legitimately completely halts, then that means that the validators will stop getting their rewards. But in this case, I think the manual intervention will be required anyway, because you might need to hard spoon the proof of work into the proof of stake. So because then the proof of work will be dead. So then number 3 is the censorship resistance of deposits. So the reason why I wanted to make it important is because there is now talks about, you probably heard about the talks of change of proof of work, and some of the arguments are predicated on the fact that, if the miners are unfriendly in the future, then they might prevent the proof of stake launch, which I trying to dig into this argument, and actually I convinced myself personally that this is not a problem, because you can actually create pretty much perfect censorship resistance for the deposit. And one of the ideas that described in detail there, it needs some details to be figured out. And at the same time, this idea also allows the individual depositors to prevent the reorg attacks, because they choose they can wait sufficient time before they reveal their deposits to the beacon chain, so that they can prevent these attacks. So I looked at also another question. I looked into the specification around the deposit data structure, and I saw that there is in deposit data structure, there is this branch, which is the array of hashes, and then index and deposit data. So I'm wondering, is this, I assume this is the Merkle proof, but when the data changes, the Merkle proof also have to be changed. So I just wonder how this is going to work. Anyway, so that's it from me. Don't want to take so much time, but any discussion is welcome.
Right. So the last question is basically that because the deposit or the deposit Merkle root in the proof of work chain changes over time, then how do you deal with Merkle witnesses proving deposits changing?
Yeah, that's correct.
Yeah, so the reason why that's not an issue is that even if the proof of work chain itself might change block to block, the Merkle, well, first of all, the Merkle root that exists within the state of the beacon chain does not change within the process of executing a single beacon chain block. And so whoever creates the beacon block is our update the Merkle branches if they have to, and then just include them. because it's all public data, and so anyone can construct the Merkle branches based off of any Merkle root if they want to. But also the Merkle roots are constant for periods of 1,024 blocks. So in general, I don't see too much to be worried about from that point of view.
Okay, so you're saying that either within this 1,000 or the 2,000 blocks, there was no need to reconstruct the proof because you just take a snapshot every whatever 2,000 block, and then if you pass that period, then you have to reconstruct the proof and then put a fresh date in there, right?
Yeah, well, it's I think the bigger thing is also that like even the person who like basically whoever creates the block has the ability to edit the proof if they have to.
Okay, so then I think this is a good good to know. It then ties to my other observation about the incentive of the validators to essentially censor new deposits. So how are we going to prevent this?
Yeah, so I thought your suggestion of making the validators rewards contingent on new validators joining was interesting.
But does that require that new validators are like, if we reach some sort of equilibrium where, given the risk reward profile of say phase 0 or 1, that no new validators are joining, does that mean that rewards are slow down at that point? I mean, does it require some sort of continuous flow? I'm not sure if I understand the function.
Yeah, I think it might need to be kind of thought through more. But another point, though, is that is that this issue is not great, especially greater for, or at least I don't see why the issue is especially greater for the proof of work to proof of stake transition as opposed to just regular operation of the proof of stake chain. Because like if at some point in the future there is some set of active validators, and that set of active validators decides that they want to and accord beacon chain rewards for themselves and not accept anyone else joining, then they will have the ability to do that.
I think Alexi is concerned about maybe like the low security and low validator count environment early on, particularly.
Yeah, it's mostly the beginning when after the beacon chain just started. There obviously will be smaller set of validators, and those so they might be more of the problem than later on when there's like a larger pool of validators.
Mm-hmm. One way that the beacon chain can know about unprocessed validators is like we are voting on this deposit route, so we're voting on this piece of information from the contract, and that could also include some sort of like index or counter, and so the beacon chain could be aware of disparity in the number of incoming deposits versus what is expected based on the deposit route. But that would still hinge upon people successfully voting on the deposit route, which would be the target, I guess, at that point.
Yeah, that is interesting. Like if we require the indices to keep on, or if we require the order in which the Merkle proofs get included to be sequential, which is something we were considering, then if it could potentially make sense to just add a rule that says that a beacon chain block should be considered invalid if it includes a root that has that has a size larger than some value, unless that has a root that contains n Merkle branches, unless like at least n minus 10,000 or n minus whatever some amount were already included.
But then the attack vector still becomes just not coming to consensus on the new.
Or not coming to consensus on the proof of work chain.
Yeah, because if you can prevent deposits, you can probably just prevent coming to consensus on the proof of work chain.
Yeah, so I just wanted to throw this in so that people can start thinking about it, and maybe we can come back to, because I've listed out the I think the problems that I see in the agenda. So maybe we can come back to these questions if there's no immediate
Yeah.
Comments.
I do want to put a couple comments about the counterfactual one. Is one, it messes with the initialization count. So if we use that from the beginning, you don't have that firm count of kind of chain start count, minimum threshold, if everyone's counterfactually doing it. And I think it's harder to construct the initial validator set. And it's also, the mechanism is tougher to prevent double spends or like double deposits over some amount. Right now, the idea to prevent double spends is to process deposits totally in order from the deposit contract. Whereas the counterfactual, you lose that, so you'd have to remember. You do remember deposits because of the pub key, so you'd have to maybe like ensure that deposits can't be past a certain age or something. Once pub keys are cleaned out, once the validator's left the validator set. So again, I think the double spend is a little bit harder there.
I'm going to think about this. Thank you. So I actually thought about this problem, but I need to think about it more. Yeah.
Okay. Cool. Any other comments on these handful of ideas before we move on? And yes, I think it's probably good to bring it up. I'll put it on the agenda for 2 weeks from now, and we can continue discussing some of the gutters.
Yeah, just a comment on the small number of validators issue. This is something that I want to study with the simulator, and I think it will be interesting to evaluate the case of a smooth transition in the number of shards. So we are right now working on a chain that has basically one shard, and instead of jumping to 1,000 shards from the night to the morning, maybe it would be interesting to see if it makes sense to do a gradual increase in the number of shards. I come from the high performance computing, and we know that scaling is hard, and we usually do the scaling smoothly. And perhaps this is something that I know that decreasing the number of shards is very, very hard, but maybe increasing is not that hard. So this is something that at least could be studied, with simulators.
Though,
yeah, I think a conservative rollout can make sense. I think the one complexity is just that it adds consensus complexity. But again, we're definitely curious
it
to
adds
see.
consensus complexity, and it would be a probably very significant change, especially given like where phase 0 already is at this point.
In terms of, I don't think it would be a huge change with respect to, it would just be like slowly unstubbing cross-link duties.
Right. Okay. No.
Rather than saying everyone who gets the cross-link
It's if the shard size was unbounded, then it would like be a really breaking. But if the shard size was just bounded and then going up to a maximum, then it wouldn't.
Yeah, I think that might be the idea, Leo, right?
Yes, that's what I meant.
Right. Okay, thank you. Anything else on this kind of range of Alexi's comments in the proof of work, proof of stake transition? And Alexi, there was an explicit mechanism added to the spec the past couple of days that instead of just voting on this deposit route in the contract, it votes on a combo of deposit route and proof of work hash. And so the finality gadget is explicitly in there to be used at this point.
Okay.
Yeah.
Cool. You did in the master, right? In master?
Yes.
Okay.
So the mechanics from the beacon chain side are there, and it would be kind of coming up with a plan and some social consensus on what that looks like on the proof of work side over time. Probably like lowering the follow distance over time. Okay.
Okay, thank you.
Great. We will move on to the next item on the agenda, which is the test formats discussion. Yannick has two new YAML test formats that have been posted. Hopefully you've been able to take a look. Yannick, do you want to just give us a quick on that? And then if anybody has any comments now, we can take them. Otherwise, we'll try to get these kind of like thumbs up approved the next day or two so people can begin using them. Yannick? Is Yannick here? Oh, yes. Great.
Okay, cool. Yeah, I think they're pretty simple. We can start with the simple serialized test. We have basically three kinds of tests, and the first one is where everything is valid. We specify the type of the thing we want to serialize, then the value, and then the serialized value in bytes, basically a hex string. And then we also have a test for invalid or values that have been serialized invalidly, for example, strings that are too long or too short. There we do not specify the value, but only the SSE string and a short description why that is wrong. And a third kind of test where the value to serialize is wrong. For example, if you have an integer that is out of range, or a byte string that's too long. Again, with a description, and then we only specify the value and not the not the SSE. Types, if possible, they're specified as strings. For example, bool, uints, bytes, addresses. For lists, we specify them as a YAML list with a single element that specifies the type of the element of the list. And for containers, we can use mappings, YAML mappings, which should not be a problem, because we for some time ago we agreed that we don't have to care about order of fields. Yeah, values, for most values we have YAML things which represent these values. Yeah, and I think all the rest is pretty straightforward. And for the tree hashing things, we basically use the same type definitions, the same value definitions, and then we just add the the tree hash of the value. Yeah. Any feedback on that? You want to change
Quickly,
something?
what was the difference between number 2 and number 3, the correct serialized value versus the invalid value?
Basically the direction. So one is we have a value and we can't serialize it because it does not match the type, basically. For example, an integer that's basically, if you want to serialize 500 as an uint 8, that's not possible. Or if you want to serialize 50 bytes as a byte 32, that doesn't work. And the other way around is if you get the serialized string and you can't deserialize it properly.
I see. So yeah, it's one has the SSE provided, one has the value provided. I see. Thank you.
Exactly.
A quick question. Maybe the first case where everything is all right. I assume that we're going to want to include some sneaky edge cases in there. Maybe it would be valuable to include a description in there as well, so that a developer can focus on what is hard to get in a particular case.
It's in the description, but there is supposed to be a short string. But I think one thing that could be valuable is so that the description is almost always the same, or there is some kind of tag, because this way you can recognize some types of edge cases.
Okay, yeah, that makes sense. And okay, adding a description for valid inputs maybe also makes sense.
Yeah, and
but maybe we can make them optional in all three cases, because maybe for some it's very boring or obvious.
Yeah, I think in the general format, the description is optional for all test cases.
Yeah, that's fair.
But Mami, you were suggesting having some sort of formal tag that can be parsed out of the description?
Because, for example, in the Ethereum 1.0 test suite, you had a lot of overflow tests, but no tags for overflow. But so it's easy to recognize. Okay, so I'll try to run all the overflow tests, and then maybe invalid types. And I don't know if I'm clear, but that's what I would like for invalid things.
So basically some way to filter the test so that you only select them, those that make sense.
Yeah, well, maybe it's too early to start that because we should start somewhere. But if we get like 5 or 10 or 100 tests because one edge cases seems to be quite tricky, it might be good to introduce tags. But that can be done later,
and
I guess.
that might be potentially. You might not want to overflow description. I mean, overload description, and might actually introduce some sort of tags construct separate, and leave description as human readable.
Yeah, I think that would make sense. I have to think about this and also what kind of tags make sense.
Right. Okay. Oh, I had one question, and maybe someone from PyVM has some thoughts. I saw that the proposed bytes format was to use the 0x prefix. I remember a couple years ago there was kind of a pain in Web3 Pi with respect to parsing some of these OX strings. I just want to make sure that we're not making something difficult here. I think it might have been maybe trying to parse the OX strings in like ambiguous contexts, and if that's the case, then this isn't really an issue. Christoph, do you have any knowledge of issues with parsing OX?
Nothing that I'm aware of now.
Okay. Yeah, I think it might have been some ambiguous context, and you couldn't really tell from the string. And so, if that's the case, it should be good here. Okay, these look generally good. I'll think about them a little bit more and add some comments. And if anybody has any red flags or whatever, please address it in the issue, and we will. I think generally just have a thumbs up on this the next day or so people can move forward.
Cool. Thanks, everyone.
Thank you. Great. So then we have the next item on the agenda is just general spec discussion. Does anybody have questions, comments, concerns about recent spec stuff, future spec stuff, etc.?
It's Terrence here. I just want to give a shout out to Danny for working on the honest validator spec. It has been really helpful. I have been reading it, and it has been helping us a lot on the implementation side.
Yeah, absolutely. That's still that's still a PR. I generally have the bones in place and plan on getting it merged and then continuing to flesh it out. But I'm glad that it has been of use. It became more and more obvious that it was needed as people kept asking me more and more questions about it. So, thank you.
Once we're a little bit more mature, maybe a document in a similar vein could be a list of suggested optimizations for implementers.
Yeah, absolutely.
I mean, yeah.
Maybe a little bit just more of a implementation guide or suggestions. Yeah.
Mm-hmm.
Spec stuff. Anything, anybody?
So I want to ask you about the container and the list format. So for the list format, there's a prefix about uh, the raw length of how the encoded the serialized encoded bits actually are for the rest of the container. Like I'm just wondering uh, like what's our consideration for this? Do we like because like because of this perfect knowledge can't really like stream the stream a container struct into bytes, but we need to wait for the full serialized byte and prefix that with the four bytes in the beginning. Just wonder like what's the consideration here? Yeah.
Right. So just to recap, I think the issue is when we've prefixed the length on the container and list types, we've made it difficult to stream.
Yeah.
I know we've discussed this here before. Does anybody have any thoughts on prefixing versus postfixing that length byte?
Main argument in favor of prefixing was that this serialization format is going to be used over the network, and for the network stuff, it's important to know how big the object that is going to be decoded, how big it is. That's why we need prefixes.
Yeah, but for like networking stuff, like you wouldn't like you wouldn't actually use the SSA format to just as is because like the SSA format is for consensus and you would like prefix it in some other data structures before sending it to the network. But one thing I think this prefix can cause some performance drawback is for the hashing there. If we just need the hash of the data structure, now that we must pre-allocate enough buffer, but we can't directly feed into a hash.
As I remember, we had a discussion about simple serialize and maybe use protobuf for network and use simple serialize for consensus. But as I remember, the final decision was to use simple serialize for both networking and the consensus stuff.
Yeah, so I already pointed out that this problem that Wei just described, that if you try to use it as for hashing, you have to pre-allocate the memory. That was exactly what I was talking about before.
But we are going like for the networking, we are going to use the lab P2P, right? But that has its own format, so like we can't like I mean we can tweak it like probably a lot, but it's not like we can use SSA or something. I think.
libp2p will produce some tools, Wireshark dissectors, if I remember, to be able to analyze whatever format we end up using for peer-to-peer networking in Ethereum, be it SSZ or protobuf or Captain Proto or something. But as of now, we will use SSZ unless, I guess, there is some major blocker. And there is a discussion open or maybe closed on the test of the old Ethereum Bitcoin chain repo about that. So you can have the whole history of the discussion with lots of inputs from Alexei.
Well, my current opinion on this is that I agree with Wei that if this format is going to be wrapped into the other packaging like late P2P, then that packaging would add necessary prefixes. So you don't need to design SSZ for that purpose. So in that means that you need to optimize for something else. If it's going to be used as an input for hashing, then I wouldn't use prefixes, as I said before.
We already have a hashing algorithm, right? I mean, the hashing algorithm that is used in the consensus part of the spec. It's also described in the simple serialization spec in the 3-hash section. So, I mean, do we even need any other hashing so far, which would work with streaming? So the point is that we have a specific hashing algorithm. So
right, but is the idea that if we fix the byte on SSZ, then we can more efficiently hash the various objects in the tree?
yeah,
I'm not sure if that would matter much because for like the objects in the tree either have a very short fixed length or if they're longer, then generally they're Merkle trees.
Right. So given that structure that we're using for the consensus hashing, that we're not doing flat hashing for consensus hashing, does this pre or postfix actually matter?
Did I get correctly that that SSZ is not using named values for serializing the elements of a structure?
What do you mean by using named values?
I mean, like in JSON, we have different fields with names, and JSON does.
Oh, so you mean like do the variable the names
Is
of
there
the
key
fields?
value stuff going on?
No, like basically what
position type.
it just gets turned into a tuple with the key and the keys are a kind of higher level human readable thing.
Okay, I see. So for me, that immediately shows a sign of a problem that might be. There might be a problem with this because imagine you have a data structure that has many different fields of the same type, and for whatever reason, at some point, for example, you need them to switch places. In that case, you might get into bugs where you have same fields of same type, but in a different place within the data structure. And for communications, it might not be necessary to cut out the named fields. But if you if you were to do that, you might run into problems of structs of two different structs that look the same when serialized.
Normally, normally SSZ we should have some kind of spec version, and so when you communicate with someone, you also spend the SSZ version you are speaking, and so you agree on the field orders and the content that way. So it's kind of the schema of the communication is written in the spec with a certain version.
Okay, well, I just wanted to weigh in on that because I think it is it gives opportunity for bugs that are very hard to trace if you, for example, forget to bump that version.
Yeah, it's very important that we all agree on our data structures in this system anyway. I don't think we're going to be changing them much. Plus, sending schemas around with these messages is just going to be a huge overhead because we have to be really careful about how much data we're sending around.
Yeah, I did some benchmark initially, like 4 months ago, and I was sending more data with the scheme. It was taking more data space than the actual data we wanted to send.
Yeah, I can imagine it's not something we might want to have. I'm convinced. Thanks.
Do we need to open up an issue to discuss this again? Or are we happy in the current state?
My opinion is that we need some numbers. I mean, some benchmarks to see how current hashing algorithm works, how it's efficient, and maybe compare it with the flat hashing, and in streaming mode. So just do some experiments and see which one is better.
Okay.
Yeah, I second that.
Yeah, and I think on the network side, I think we were going to wait until we were actually pushing packets around on a network to be able to make a more informed decision on whether SSE was going to be utilized there or not. So let's continue forward as is for now and address this when we have more information. Okay. Xiaowei pointed out to me that we have this PR that we've all known and loved and been maybe 1 second. 139 that recently Justin approved. Generally, the arguments laid out favored slightly in the direction of Little Indian. Does anybody, and it also helps Substrate because they only support Little Indian right now. Does anybody feel very strongly about merging this pull request that has been sitting here forever?
What are the arguments for Little Endian again?
Justin listed consistent with WASM, consistent with commodity hardware, consistent with parity codec. Cons, inconsistent with RLP, inconsistent with big
that's
number
right.
implementations.
Okay, wow, wasn't those a Little Endian? Okay.
I know, Vitalik, your argument a while back was to not change the Indianness from 1.0 because then you have to remember, and that's just cognitive overhead for pretty much not much gain at all. Given the context
Yeah.
of WASM, is that still true?
Yeah, I guess fine.
Okay. I think this is a major win for Jacek. He's held out for a long time. And we can merge after the call. Cool. I think a bunch of people might be in the Stanford area at the end of January. I think at least some amount of us might be in East Denver in the middle of February. So we should get together and communicate about that offline. I don't think we're going to do a specific event unless somebody else feels like organizing something. Cool. Any further spec discussion, any further comments, questions, anything before we close this meeting? Great. Thank you all for coming. Really exciting to see all this progress. As always, communicate in the getters. We're going to start versioning on the spec repo and talk to you all in, I think, 2 weeks. I haven't looked at my calendar, but I believe 2 weeks. Okay, thank you.
Thanks, everybody.
Thank you.
Thanks.
Thank you.
Thank you.
Bye-bye.
Thanks, bye.
Thanks. Bye.
Thanks and bye.
Thank
Bye,
you.
guys.